Flying Eagles appears to be a simple ride, but exhibits many different physics concepts. The ride is a spinning pylon which has arms sticking out of it. There are cars attached to the arms with chains. When the ride begins, the pylon rises upwards and begins to rotate. The cars have a vertical wing at the front which allows riders to direct it from side to side. Based on these factors, the physics concepts we are going to address in this video are forces, centripetal motion, and fluids.
Following are the dimensions for the ride. The ride is about 8 meters tall and has a radius about 3.5 meters when at rest. The height of the front wing is about 1.25 meters.
Although we collected large amounts of data while on the ride, the limited capabilities of our phones made the majority of the data useless. This was because our phones could only measure values like acceleration, velocity, and rotation along the X, Y, and Z axis of the phone. When we brought our phones on the ride, the axes of the phones moved around and no longer related to the X, Y, and Z coordinates of the ride. Because of this, the only useful data we could gather was the measured acceleration due to gravity, as the phone used an internal rotation vector to calculate this with respect to the world.
However, because centripetal motion has no vertical acceleration, the acceleration due to gravity is constant. Because it was not possible for us to collect data with the technology we had available, let's discuss the physics concepts behind how this ride works. Here's a free body diagram for the ride. The three main forces acting on the ride are the force due to gravity, the force of tension, and the force due to the air. When the ride is in equilibrium, the force of gravity and tension directly cancel out and there is no force due to the air. However, when the ride is at full speed, the x component of the force of tension causes centripetal acceleration while the y component opposes gravity. In addition, the force due to the air acts to oppose or add to the forces of gravity and tension depending on the orientation of the front wing. The centripetal motion in this ride occurs because the pylon is spinning and the force of tensions in the chain provides centripetal acceleration. The centripetal acceleration opposes the inertia of the cars, causing riders to feel an outward pull when in reality there is only an inward force. The final physics concept of this ride relates to fluids. The wing on the front of the car causes it to move for two reasons. The first is that there is air resistance acting on the wing, which causes the force to push the car. Secondly, the wing on the front of the car acts like the wing on an airplane. When it is tilted, the wing causes air to move more slowly behind it, while it continues to move quickly on the other side of the wing. This creates a high pressure pocket behind the wing, and because fluids tend to move from high to low pressure, the air pushes against the wing to move the car. The centripetal motion causes riders to feel the pull of inertia, and the wing allows them freedom to fly around. Flying Eagles is an enjoyable ride because of its implementation of physics concepts to provide a thrill.